welcome to this CritterQuest progress report. Since it's the first one, I'll be going over the project's core idea, as well as the work that I've gotten done in Engine so far. So, the mechanic at the heart of CritterQuest is pattern recognition. The original inspiration for it involved humans being cursed and transformed into animals, and it's the player's job to point out which is which so that the curse can be lifted. So far, I've been working on getting the base AI tree implemented using Unreal Engine 5's new state trees, as well as a nice asset pack of crows. Or ravens. It's used interchangeably, and I'll be using it interchangeably in the videos. And I've implemented the player controller as well, win and lose conditions, and the menu used to make your selection. We'll start with the level blueprint. It grabs the player controller to activate a timer-based lose condition later on, as well as to assign the player controller's array of ravens to use for the evaluating the choices that are made. The array is filled with using pre-placed actors in the level, and it's cycled through at begin play in order to pick one of them to become the variant. Once it's done with that, it sends the full completed array over to the player controller in order to fill in that variable. On take it checks for a timer. I'd like to add the time to a HUD widget later, but most of my focus has been on the AI lately. The player controller blueprint is used primarily to keep track of the selection menu and its required data, as well as activating the win and loss states, as well as the widgets. The selection menu is incredibly simple visually, with 5 buttons representing the 5 ravens. It checks whether the raven at index button -1 is the variant, and it responds accordingly, either by activating the win state or by subtracting guesses, which is the other lose state, is you get 3 guesses at the beginning, and then you get 90 seconds. The win and lose widgets are just super simple. You have the same code of restarting the level or just quitting the game. Alright, so let's take a quick look at the state tree itself. You're able to assign a context actor to the tree, which allows it to get data from the actor that it's controlling, which in our case is the BP Raven. Now, the state tree is attached to this blueprint because when I attached it to the AI controller, it was not very happy when I tried to play animations off of it. There are pathfinding components used, but those are used later, and you could cast to the AI controller for that. I have an instance editable variable for the skeletal meshes material, so that it can be selected in the level editor and assigned on construction. Begin play is fairly simple. I have it set the movement mode to walking because I'd like to include flying at some point. And then I call in the generate tasks function. To make sure only those who are truly paying attention and have learned the bird's routines can succeed, there's 2 choices per task, a regular one and a variant one. The variant is assigned 2 variant tasks in this function, while all the other regular crows are assigned 1 variant task and 2 regular ones. This array here of var index keeps track of which path each task takes, and it indicates it's set by default to 0, and it indicates which one's the variant by putting in a 1. That is not. This array of 3 elements keeps track of which path each raven's supposed to take. Now, all this data here in the Raven blueprint is accessible in these different tasks via the context variable that we have set here. However, there's another process that's going on in the background as essentially a state machine manager, as far as I can tell. It's called a state tree evaluator. At the moment, I'm not quite sure the full potential of it, but I'm looking forward to learning it. And currently, it's just keeping track of whether there is one of the active action states, as I'll show you in a second, and assigns this variable as state accordingly. Now, let's get to the tasks. So the first one, state tree task, or STT underscore choose state, runs a task to randomly choose one of the 3 available action states, idle, move, or call. Choosing between 0 to 2, it then sets the current state variable in the Raven to that integer, which is then used in the var index in order to choose the task, rather than the default, which is -1, because there's no task going right now. Then, once it chooses one of those 3, depending on which one it was, it switches on an integer and enables the corresponding boolean. Then, given that the boolean is checked on tick in the evaluator, it should be able to see that we've had a state activated, and boom, has state is true. When both this is true and and current state does not equal -1, that'll allow it to move into the next state, which is action. So each state here, selection, action, and wait, have enter and exit conditions that should block them off from each other at different times, depending on different tasks and statuses. The state tree evaluates top-down, but searches for the first leaf node that it can enter, given active conditions. In this case, for action, it'll want to choose one of these three, depending on which Boolean is activated. So action has an integer compare and a Boolean compare for both its enter and exit transitions for the exit conditions. And they correspond with some of the exits and enters in select and wait in a way that it should be that you can't be in all three of these at the same time. And you should be able to move on to them in a direct linear line, one right after the other. So STT idle, move, and call all start in the same overridden receive enter state function that is called when you enter the state. That calls events within, So these each call events on the event graph because all of them use some kind of latent function, like delay or like move to. And then this one also sets the variable to false in here, which we'll get to in a second. It's just easier to do it here because it's a mess over. It's a bit of a mess over in the other event graph. So all three of these tasks start with the var index little array getting pulled from the Raven, and then pulling the value for the corresponding event, which is 0 for idle, and then 0 for idle, 2 for call, and 1 for move. Yeah, there we go. So now this will read. If it's equal to 0, it'll go to the regular, and if it is not, it'll go to the variant path. So now for this one, and for idle and for call, it plays an animation using the skeletal mesh component that you grab from the context actor, and then delays the amount of time that the animations play. Now these are just composite animations that I threw together from some animations that came in the asset pack that I got the Ravens from. And then at the end of either path, it jumps in and it sets is idle back to false. That way it can exit this condition. And it sets is idle to false. So it should be able to exit the state and move on to the last one. And move on to the last one. Now it's similar for this. It's the same animation in this case. However, the variant one is a duplicate and there's different sound effects placed at different points. Now move is a bit more complicated. Still needs a little bit of debugging, I think. Oof. There's a series of 6 actors here of type BP flight spot. And now all 6 of these have at least one tag. 1 and 2 have move 1, 5 and 6 have move 2, and 3 and 4 have move 1 and move 2 to spice things up a little bit. So depending on the variant, it'll get all actors of class with tag, move 1 or move 2, and then it'll make that into an array of 4, and then between options 1 through 4, it'll get one of the elements of the array randomly, and then it'll check if the crow is already there. If the crow's already at that actor, close enough that it registers as at that actor, it'll move 20 Unreal units along the positive Y or X axis, depending on which move function it is. But if it is not there, it'll move towards the actor, which I don't think I need location and whatever, I'll leave it in there. It'll move towards the goal actor, which is the flight spot itself. And then it'll return, set is move to negative as well, and bam, succeeded. Now that the task has been executed, and these are all 3 set back to false, no matter what's going on, the evaluator will be able to set B has state back to false as well, which will allow it to leave the action state and enter the wait one. Now the wait state has its own task, which is STT rand time. Now on start, it plays a looping animation of just the basic idle animation, and then calls a wait random time function, which returns a random time between 1 to 5 seconds, and then delays for that long. And then it returns back to, and then it returns back to the enter state function, sets the current state back to -1, and then return success, because that way it's not equal to -1 when it enters, but it will be equal to -1 when it leaves. And then that way it'll return to here, where it's equal to -1, and it does not have a state. And so that way, theoretically, it should be able to loop. So at the moment, my biggest roadblock is trying to figure out why it just keeps entering new states instead of entering one and then waiting. Even with the latent functions that I've added, because for a while that was my problem, was I'd just do simple move to and it would refresh every tick. But now all the proper variables are set and ready before I start the logic tree. Everybody's calling now. Except they're not. Why aren't they calling? Oh my goodness. Well, as you can see, I make sure all the tasks are generated before I start the logic, so that there's nothing screwy going on with the booleans and all that. As well as... that might be something to work on for the next update, but yeah. Not quite sure why it's continuously iterating on itself, but I will certainly see if maybe calling generate tasks from here as opposed to in the array, not the array, as opposed to in the blueprint, as opposed to in the Raven blueprint, might work better. But for now, that's what I have to show. Yeah, so thank you for watching, and I will be sure to update this series the more that I work on it.